All right, so now that we've seen the theory behind the chain rule, let's start by doing a pretty simple and straightforward example. Right? Now, this example is easy enough that you could just take this x and y, plug it in here, and do the derivative. But we need to start understanding the theory behind this. So what we're going to do is we're going to do this derivative using the chain rule theory. And then, in fact, as a good exercise, what you could do is plug those back into the function, take the derivative, and see that you get the same thing. Okay, so let's begin by finding the things we need to find. Well, one thing we're going to need to do is figure out what is the g of x? What is the change of variables here? Well, or sorry, not g of x. It's g of the new variables. Well, there's only one new variable in this case, and it's just t. So it's just g of t this time. So the first component of g should be the x component, sine t. The second component of g should be the y. So just e to the t. All right, now we're going to need to do a few different things. Okay. We're also, one of those things is we're going to need the gradient of f. All right, so let's find that. Gradient of f, well, first we take the partial derivative with respect to x. That's going to give us 2x plus y. And then we take the partial derivative with respect to y. That'll give us 2y plus x. All right. So now we need to do two more things, and then we can finally do the chain rule. Right? So the first thing we need is to plug g into the gradient of f. All right? So when we do that, we get 2, remember this is x, this is y, so 2 sine t plus e to the t, and then 2 e to the t plus sine y, or sine x, sine t. If you just say enough letters, you get the right one eventually. Right, so that's plugging g into the gradient, which is the same as taking these two guys and plugging them in. That's the point of g. All right? Now we have to find the partial, well, it's not really a partial derivative here since g only has one variable, but if you use the curly d's for the partial derivative, it's fine too. No big deal. All right, well, that derivative is cosine t e to the t. Right, that's the derivative of g with respect to t, just component by component. Okay, so now we can finally do the chain rule and find dz dt. Right, remember, this is just the gradient of f where we plug in g of t, dot product with dg dt. Okay? And then now we just do the dot product. So 2 sine t plus e to the t times cosine t. We're going to get 2 sine t cosine t plus e to the t cosine t. All right? And then we do the second components. And right, now we have 2 e to the t sine t times e to the t. So plus 2e to the 2t plus e to the t sine t. Right? And then you'll see here there's actually nothing that combines, so this is the final answer. Well, this over here. Okay? So that's a pretty straightforward example. Hopefully it's pretty simple, and it's pretty easily understandable. And again, if you're not sure, and it's just sort of good practice anyway, plug these guys back into this function here, and then take the derivative with respect to t. And then you'll see you get the same answer.